Hello there, smart people. I am the scientific puppet. Are you interested on how the Blessed Trinity concept can scientifically be supported as logical? If so, stay tuned. You will witness how science meets religion. As a foretaste, consider the statement: a quantum mechanical system and a Christian God have similar dynamics. If this statement is very unfamiliar, then you have more reason to watch further. The Blessed Trinity concept is one of the most challenging Christian beliefs to defend as being logical. For example, non Christians argue that one God plus a different God plus another different God cannot be one God. That is, the Blessed Trinity concept is illogical for them. Further, Jesus Christ said in John 14:28 that the Father is greater than I. How could they be one, meaning equal, if one is greater than the other? There are various attempts to support the Blessed Trinity concept as logical. They are exercised by using logic derived from human experiences of the macroscopic world, that is, the world that can be seen by unaided human eye. Just a side note, if you are interested on these attempts, you can refer to references listed below numbered 1, 2, and 3. These attempts will not be dealt further here, as they all failed to support the Blessed Trinity concept as logical. It is important to note, however, that their failure might be due to the use of logic derived from the macroscopic world. As supported in reference number 4 below, it is from our experiences of this macroscopic world that we humans formulate logic. For example, we observe in our macroscopic world that there is nothing we can do at present, say study diligently, to change the past, say make your past grades higher. Thus, it is illogical for us to say that you can do something at present to change something in the past. This statement is called retrocausation, a concept we will return to later. As deriving logic from the macroscopic world would not lead to the support of the Blessed Trinity concept as logical, it might be better to derive this logic from a non-macroscopic world. An example of a non-macroscopic world is the atomic world, which is comprised of entities that are extremely small, such as electrons and protons we learn in high school, so small that they cannot be seen by naked human eye. The atomic world is investigated in the domain of science called quantum mechanics. Thus, quantum mechanics is used here to support the Blessed Trinity concept as logical. Yes, in the foregoing discussion, science meets religion. Don't worry, the discussion can be understood even by a high school graduate person. You may read the reference number 5 below for the fundamentals of quantum mechanics. However, reading this reference is not necessary for the following presentation. To begin the presentation, let us review the physics of waves, like waves in the shore. Waves are propagated effects and not traveling particles. For example, the effect of banging a drum propagates through air around this drum and yourself and reaches your ear, thereby you hear the sound of the bang. Note carefully that the air molecules do not travel from the drum to your ear. Rather, the banging effect does. You may read reference numbered 6 below for the physics of waves. However, reading this reference is not necessary for the following discussion. Waves have several characteristics, but the only characteristic pertinent to our discussion is the result of wave interaction called interference pattern. If you are already familiar of this pattern, you may skip to the playing time of this video indicated below. Otherwise, what is interference pattern? Consider a figure of an imaginary pool of yellow-colored still water where there is a black-colored blockades having two slits or openings. This setup is for our imaginary experiment referred to here as the double-slit experiment. In this experiment, suppose that the part of the water beside the center of the leftmost side of the pole is repeatedly disturbed. The effect of this disturbance is propagated in the pole as waves. The propagated effect consequently changes the water surface shape in time as shown in the video. The vertical height of any point in the shape is represented by color ranging from white, which represents maximum height, to yellow, the reference height, and finally to red, the minimum height. Now, in the video, some waves travel from the disturbance source to the two slits, then reach the rightmost side of the pool where they meet and interact. The time-varying shape of the water beside the rightmost side of the pool is important to our discussion. This time-varying shape is shown enlarged and rotated in the adjacent video, and whose points have reference height indicated by the yellow vertical bar. Note that even though the shape varies in time, it keeps on repeating, say with a period denoted as capital T. The time-varying shape will be fed to a mathematical process as follows. Given a coordinate x at the rightmost side of the pool and time t, let y function of x and t denotes the instantaneous height of the point in the shape of the water at coordinate x. To implement the equation shown, square the instantaneous height, integrate the squaring result over the repetition period capital T, divide the integration result by this period, then take the square root of the quotient. The result is the value capital I function of x that varies with the coordinate x. Repeat this mathematical process for each coordinate at the rightmost side of the pool to obtain the curve shown in the figure referred here as the interference pattern. Don't worry much if in case you don't understand the mathematics. The important idea to bear in mind is first, if we project the middle of the two slits to the rightmost side of the pool, the projected point coincides with the center of the middle hump in the interference pattern. The projection direction is indicated by the red arrow in the figure. Second, the interference pattern is the result of the interaction at the rightmost side of the pool of the waves coming out from the two slits and then meeting at the interaction location. Let us now contrast waves with particles. If the machine gun in the figure fires bullets, which are particles, at the gray wall that has two openings, one may get bullet holes at the white wall as shown. Let us count the number of bullet holes at the white wall enclosed by the red imaginary vertical strip with height as tall as that of the white wall, a given width, and center located at the horizontal thick red line axis. For example, when the strip center's location is 3 meters from the horizontal axis origin, the number of holes it encloses is 10. The location and count constitute a point indicated by a small circle in the figure. Now repeat the counting process but with the vertical strip center at various locations in the horizontal axis. This yields points indicated by the small circle in the figure that when connected may produce the two hump pattern shown. Noticeably, there is no middle hump, and the center of any of the two humps does not coincide with the projection of the middle of the two openings to the white wall. The projection direction is indicated by the blue arrow. Clearly, the two hump pattern is different to the interference pattern, which has its middle hump center coinciding with the projected middle of the two slits, as shown. These different patterns distinguish particles and waves. That is, in the similar two opening experimental setups, waves form interference pattern, while particles form the two hump pattern. The other difference between particles and waves is that in the double slit experiment, a single wave can travel in two different paths simultaneously, where one path is from the disturbance source to one slit, then to the rightmost side of the pool, and the other path is from the disturbance source to the other slit, then to the rightmost side of the pool, where the waves from the two slits interfere. Sample wave direction is indicated by the blue arrows in the figure shown. On the other hand, in the machine gun firing experiment, a single bullet cannot travel simultaneously on two different paths, where one path is from the gun to one opening, then to the white wall, and the other path is from the gun to the other opening, then to the white wall. Sample bullet direction is indicated by yellow arrow in the figure above. Further, even if there is one bullet traveling on each of the two different paths, they cannot meet nor interfere with each other when they simultaneously arrive at the white wall. Now, instead of bullets, how about electrons are the ones being fired in a setup analogous to that of the machine gun experiment? Suppose, instead of the white wall, let us have a photographic screen which produces a yellow spot at the point where the electron strikes it. That is, the yellow spot is analogous to the bullet hole. Let us call this setup as the double-slit electron firing experiment. Next, let us apply the vertical strip used in the machine gun experiment to the double-slit electron firing experiment. However, let us make its width to be very small and its height as tall as the photographic screen. Now, let us count the number of yellow spots on the screen enclosed by the vertical strip. Then repeat this counting process for various locations of vertical strip center on the blue horizontal axis. Finally, plot the counts against the center locations to obtain a pattern. What pattern we might obtain? Before answering this, bear in mind that several experiments showed electrons not as waves, but rather particles, like bullets, such as those manifested in the photoelectric experiments described in reference numbered 7 below. Thus, based on the previously mentioned distinguishing patterns between waves and particles, the expected answer to the question is not interference pattern, rather a two-hump pattern. However, the experiment of Tonomura and others, similar to the double-slit electron firing experiment, but with only one electron fired at a time, obtained an interference pattern. You may read the reference numbered 8 below for further details of their experiment. But how come they obtained an interference pattern and not a two-hump pattern, considering that electrons had been shown to be particles and not waves? This dilemma was resolved by physicists using the logic-defying idea that, in the experiment of Tonomura and others, each of the individually fired electron behaves as a wave. In-depth exploration on the wave-like property of electrons can be read in the reference numbered 9 below. Now, being a wave, the electron in the double-slit electron firing experiment illustrated in the figure can be viewed as though it travels on path P1 that starts from the electron gun to the right opening, then to the screen, and simultaneously it also travels on another path P2 that starts from the electron gun to the left opening, then to the screen. Then, the electron on both paths interacts in a wave-like manner when it arrives on the screen to form the interference pattern illustrated in the figure. The term wave-like interaction means, from here onwards, as a type of interaction that yields an interference pattern. Now, note that there is only one electron that travels on the two different paths simultaneously. That is why I did not say the electrons on the paths interact in a wave-like manner when they arrive on the screen. The behavior of electron in the double-slit electron firing experiment has several quantum mechanical interpretations. As these interpretations are crucial for the foregoing discussion, let us formally enumerate them as follows. 1. There is only one electron but can travel on the different paths P1 and P2 simultaneously. 2. The totality of the electron on the different paths is 1, and the same electron as itself. In other words, one electron in path P1 plus another electron on path P2 equals one electron only, and not 2. 3. By being traveling in path P1, the electron is said to be in a quantum state psi1. And by being traveling in path P2, the same electron is said to be in another quantum state psi2. Thus, the state of each electron in the different paths is a unique state of one and the same electron as itself. 4. By being traveling on different paths simultaneously, the state psi of the electron is the superposition of the quantum states that correspond to the different paths. The superposition is mathematically expressed as psi equals psi1 plus psi2. 5. The electron on each path is not a part, nor a clone of, but substantially the same electron. 6. The electron on the different paths can interact among itself at the convergent end of the paths. Note the unusual sentence construct. This enumeration is called the two-path statements. The idea that the solitary electron can travel on two different paths simultaneously and then interacts in a wave-like manner with itself at the end of the converging path is absolutely weird, magical, and illogical in layman's view. But it even gets weirder. In quantum biology, a single molecule called exciton can seemingly travel in not just two, but hundreds of different paths simultaneously. This idea was used to explain photosynthesis, the process of converting light to energy in plants. The exciton is viewed in quantum mechanics as being in a superimposed hundreds of different quantum states. Further details in this mind-boggling quantum mechanical topic can be read in the reference number 10 below. There are also seemingly illogical quantum mechanical ideas not directly related to the wave nature of particles. One is the idea that a single cat can be alive and dead simultaneously. The live cat is said to be in one quantum state, and the same cat, but dead, is in another quantum state. The simultaneity of the cat being alive and dead is due to the superposition of the two quantum states. This idea, based on the thought quantum mechanical experiment devised by the Nobel Prize winner Erwin Schrödinger is so profound that the cat was named as Schrödinger's cat. 2. Seemingly illogical quantum mechanical idea is that the present can influence the past. That is a retrocausation which was previously mentioned as being illogical. As bewildering as it is, this idea is supported to be true in the delayed choice quantum eraser experiment on laser, described in the references numbered 11 and 12 below. Amazingly, the various weird and seemingly illogical ideas already presented and based upon the observations on the atomic world are accepted by many physicists as true. Persuaded by this weirdness, the Nobel Prize winner Niels Bohr said in page 36 of the reference numbered 9 below, and I quote, "Up to this point in the development of scientific knowledge, it has always been possible, to a greater or lesser degree, to build in our minds a visualizable image of the workings of the world. But we are now presented with a situation in which such visualization is impossible. In entering the atomic realm, we have entered a world in which our very ideas of what human knowledge can achieve need revision. Reality can no longer be thought of in the terms we have become used to." End quote. What Niels Bohr implied is consistent with the idea in the reference numbered 4 below, that logic is not fixed, but rather dependent on the considered world, such as the atomic world. The important lesson here is, in a world different to our macroscopic world, which we see with our unaided eye, we may use a different form of logic, and the logic we learn in our macroscopic world may be inapplicable to explain phenomena in that different world. Let this lesson be labeled as prime lesson. Considering that the atomic world is different from the macroscopic world, the prime lesson persuades the acceptance of the various previously mentioned weird quantum mechanical ideas as logical when dealing with the atomic world. Indeed, as previously mentioned, many physicists accepted the idea as true. The ideas include the two-path statements, which are then accepted here as logical. This acceptance is the first step, as depicted on the figure, towards supporting the Blessed Trinity concept as logical. Now, let us apply the logic on the two-path statements to a setup where a single electron traverses three paths simultaneously and has three quantum states, namely psi1, psi2, and psi3. This application, the second step in the figure, yields the new enumeration shown, called the three-path statements. The three-path statements are accepted here as logical since it abides by the quantum mechanical principles accepted as true, despite seemingly illogical as previously discussed. Soon we will contrast the three-path statements with the statements claimed here to describe the Blessed Trinity concept and are as follows. 1. There is only one Christian God, but can be God the Son, God the Father, and the Holy Spirit simultaneously. 2. The totality of the three divine persons, that is, the Blessed Trinity, is one and the same Christian God as each of them. 3. Each divine person is a unique state of one and the same Christian God as itself. 4. Each divine person is not a part nor a clone of, but substantially the same Christian God. 5. the three divine persons can interact among themselves. This enumeration is called the Blessed Trinity statements. Now, let us proceed to the third step, where the variables of the three-path statements are replaced by those of the Christian God. This step is akin to the replacement of the word birds with the word fighter jets in the statement birds can fly to obtain the statement fighter jets can fly. To perform the third step, let the Christian God replace the electron in the three-path systems. And the three divine persons one-to-one replace the electron in three different states. As depicted in the figure, God the Father replaces the electron in state psi1, God the Son replaces the electron in state psi2, and the Holy Spirit replaces the same electron in state psi3. The replacement is between entities in the two related worlds, namely heaven, where the Blessed Trinity is believed to reside, and the atomic world, where the electron resides. The two worlds are related in both having logic expected to be different based on the prime lesson to that derived from our macroscopic world. This relationship gives merit to the replacement. We now arrive at the crux of our discussion. The replacement transforms the three-path statements to the following enumeration. 1. There is only one Christian God, but can be God the Son, God the Father, and Holy Spirit simultaneously. 2. The totality of the three divine persons, that is, the Blessed Trinity, is one, and the same Christian God as each of them. This logic defies the logic derived from our experiences of our macroscopic world, where, adding the Sumerian moon god Nana, the Roman god Cupid, and the Hindu god Krishna yields three gods. Again, based on the prime lesson, we must not apply the logic derived from our experiences of the macroscopic world to that of the different world, such as heaven, which is inhabited by the Blessed Trinity. 3. Each divine person is a unique state of one and the same Christian God as itself. 4. The state of the Blessed Trinity is the superposition of different quantum states of the one Christian God. This conclusion and the totality of the three divine persons as described in item 2 define the Blessed Trinity. 5. Each divine person is not a part, nor a clone of, but substantially the same Christian God. 6. The three divine persons can interact among themselves. An example of divine interaction is Jesus Christ praying to God the Father. This can be used to explain why Jesus Christ prays to his Father even if he is a God. Excluding item 4, this enumeration demonstrates that the replacement of the variables in the three-path statements by those of the Christian God incredibly yields the Blessed Trinity statements. This shows that the three-path system and the Christian God have similar dynamics. The three-path system resides in the atomic world, and the Christian God resides in heaven. Each of these worlds is different to the macroscopic world. By the prime lesson, the logic of the Blessed Trinity statements and the logic of the three-path statements are similarly expected to be different to the logic derived from the macroscopic world. Now, here comes the most important part. Based on the two similarities, the Blessed Trinity statements can be accepted as logical since the three-path statements are accepted as logical. We then have proven our thesis. The Blessed Trinity statements can be supported as logical. The support makes use of the scientific quantum mechanics. Thus, the support of the Blessed Trinity statements as logical is scientifically based. Lastly, let us answer the question, why did Jesus Christ said in John 14:28 that the Father is greater than I? To answer this question, we will depart from physics. As believed, God the Father begot and did not created God the Son. However, without the Father, the Son would not exist, since the Father begot the Son. Thus, although not created, the Son owes his existence from the Father, the source of all existence. In this sense, the Father is greater than the Son. Thank you for watching. Please subscribe by clicking the button below and post your comments. I would highly appreciate it.